The satellite industry is going through a digital transformation. In this episode of On Orbit, I'm joined by a group of experts representing RF manufacturing and both parabolic and electronically scanned antennas for a look at digitization at the edge. You'll hear from Simon Swift, Engineering Director of ETL Systems, Dave Nicoll, Strategic Business Director of Holkirk Communications, and John-Paul Szczepanik, CTO of All.Space. We talk about what digitization at the edge looks like for both conventional antennas and ESA terminals, and how it allows users at the edge with small portable terminals to have the resilience of multiple networks. This conversation is sponsored by ETL Systems. I'm Rachel Jewett, and you're listening to On Orbit, a podcast that asks, what's our future in space? We've got a great group here today for a discussion about digitization at the edge. I am here with Simon Swift, Engineering Director of ETL Systems, Dave Nicoll, Strategic Business Director of Holkirk Communications, and JP Szczepanik, All.Space CTO. There's been a lot of momentum around digital IF in the satellite industry in recent years. And I know that some of you are involved in the Diffie Consortium, which I'm sure we'll talk more about. And you all are coming from different areas of satellite ground systems. So to kick the discussion off, I'll have you all introduce yourselves and tell us a little bit about your companies. Simon, let's start with you.
Okay, well, thank you for that, Rachel. Simon Swift, I'm the Engineering Director for Digital Systems at ETL. We've been in the industry for God knows how many years. We're about 30 years into RF. We supply pretty much every manufacturer, every distributor, every satellite industry around the world. I'm also the chair of the specification working group for Diffie. We did say we'd get on to Diffie later. Our particular interest here is the production of digitizers. So we produce RF hardware. Most people are getting out of the hardware business into the software business. We're very much firmly planted in that hardware business, but expanding our roles.
Awesome, thanks. And Dave, tell me about yourself and a little bit about your company.
Okay, Rachel, thank you very much. My name's Dave Nicoll. I'm the Strategic Business Director for Holkirk Communications. I've been, like Simon, playing in this business for many, many years. Holkirk's been going for 21 years, supplying traditional parabolic tactical terminals to secure customer base. How I've got involved with Diffie and certainly the Edge terminals is through Simon. Looking at his technology and looking how we can bring this new wonderful thing of RF over IP into a secure domain for tactical advantages.
Awesome. And then JP, introduce yourself and a little bit about All.Space.
Thanks, Rachel. Really appreciate having me on the podcast today. My name's John-Paul Szczepanik. I'm CTO of All.Space, and we're really pioneering the next generation of multi-orbit, multi-link user terminals. I've been with All.Space for 5 years or so, and prior to that, I was CTO of Phaser for 7 years. So I've really been in the middle of the kind of current SATCOM ground terminal evolution, or even sort of disruption that's happening at the moment, and for the past sort of decade or so, and been pushing all the way through that, trying to get to this sort of utopia of that full digitization that we're going to talk about. So yeah, for me and at All.Space, the digitization at the edge actually has kind of a couple of layers to it in my mind. The most kind of fundamental level is this move from both parabolics and L-band interfaces to a kind of a modern world of the electronically scanned antennas and software-defined antennas. And then, as we talked about, the Diffie, the digital interfaces, is a key part of that enables a lot of that transition. But for All.Space, that's the fundamental kind of scaffolding, and the real kind of digitization at the edge is what's exciting, and it enables the features and the software services like software-defined modems, software-defined networks, SD-WANs, that you can kind of start to build on top of that. So that kind of higher level, the sort of virtualization of a lot of these subsystems is what's exciting for us.
Yeah,
I think it's safe to say that actually a lot of that has already been happening very much at the ground segment. We've been talking about that a lot over the over ground system, over RF distribution over long distances. What we're talking about here, though, very much with edge devices, is thinking, well, hang on, we've got all these benefits that we're starting to get of virtualization, containerization, of software modems, of being able to have the same modem, the same hardware running multiple different modems at any one time. So that's surely going to be a benefit tactically to people at the edge, people who have to be in a place where they need to be able to switch between systems. We've talked a lot about multi-orbit, multi-constellation, multi-X is the big buzzword in the industry. And I think that is really enabled by software modems and digitalization. And I think really bringing that to the ground user terminal is what we really care about here of edge devices. Wouldn't you say so, Dave?
Absolutely. And I was going to add to that, Simon, and that's why something like this is so important. So you've got two technologies here. You've got the new multi-orbit scanning array of All.Space and the traditional parabolics as well. Because what Diffie is going to offer is what my customers are asking for. It is the panacea of the way satellite communication is going, and that's before we wind in the 5G convergence and other sorts of waveforms. But when we've spoken before about the whole digital IF networks, edge terminals is always that one little subject that people sort of scan over. So I think it's very important to have these sort of conversations and get it out about what is going to be useful in the field for the tactical end user.
Okay, so I want to set the context a little bit for the conversation. When we say edge devices, what do we mean by that? What are we talking about?
So we're talking about anything that's servicing a single user or a small group of users, as opposed to the gateway where you're hosting the whole multiplicity of users. So whether we're talking about maritime, whether we're talking about land portable, whether we're talking about man portable, or even a small gateway repeater, that's the sort of thing we really mean by the edge. We mean the small portable terminals.
Yeah, and for my customers, that's exactly right, Simon. It's Diffie works very well for distribution of signals. We know over the years going from a copper wired solution to fiber, now to IP. But when you come into the field, when you come into the place where you're operating a single edge terminal, you haven't got any IP. You are that IP node. So that's what I call the edge terminal, Rachel. That's the thing where a one sole user is communicating to the Diffie network.
Mm-hmm.
Yeah, I definitely would just pick up on that because I think it's a really important point that, we're no longer talking about kind of the edge device being a passive endpoint. It's kind of becoming an intelligent node in a distributed and hybrid connected system, and that's a big change that we're seeing. It's a big demand from the end users to have that resilience, and that's what's key, particularly for All.Space, with a bit of a focus on defense customers in particular. It's around that being as resilient and as capable and as flexible as possible, that edge device, and that really is delivered through digitization, to be honest, and a software defined solution. And also the edge, that endpoint, is becoming much more hostile, as we know. The environment that we're working in, the contested environments, resilience is key. That needs flexibility, that needs multiple networks, and that needs digitization at the end of the day.
Mm-hmm. So I think that we've already been kind of talking about this, but the benefits of digitization at the edge. So what this change means and the benefits that brings to the customers. Simon, we can start with you.
Okay, so I think just going back a little bit in my career, I spent about 10 years in the electronic warfare industry and understand a lot about this more hostile environment and about the ruggedized environment these terminals sit into. And one of the key things there is swap, size, weight, and power. So just think, if you were to try and carry 6 different modems with you for different constellations, how heavy that would be and how much power potentially that could consume if you had to have all of these on hot standby. If you compare that now with having a single set of digitized hardware and then being able to load in whichever particular modem you saw that you needed at any one time, or even having multiple of those running at any one time, I think that brings a fantastic benefit to the end user. And the ability to adapt. JP had mentioned resilience and reliability. If you think maybe take away from the military into maybe something like the disaster relief scenarios, you turn up in a country and you've got limited satellite coverage or different limited constellations you can actually get coverage from, you're in a denied environment. Again, that flexibility to be able to interwork with the local area has to be a huge benefit for people.
Yeah, what we work on is the pace approach, and that's exactly the primary outputs would be a standard ruggedized hardened modem platform. Now the alternative, you can switch with a lot of the next generation LAN terminals, you can switch orbits, you can switch to different satellites. The contingency side of things, we can use a different frequency. An emergency, we can just use commercial satellite space. But as Simon said, what that means is what our customers have done up until now is carry different interchangeable modems. What this is going to give us is a software-defined way of producing waveforms, which will then link into the ground station, and all that power-hungry modems, 19-inch rack equipment disappears. So that's what it means to me and my customers.
Yeah, definitely. I think that it boils down, and we've seen it time and time again when we talk to our customers, for us, down into three categories, and I think Simon and David just covered it, but it's flexibility, definitely, where digitizing the signals inside the terminal and then no longer needing to get to that, it'll go back to the RF world, provides that flexibility. It's then the resilience, having multiple networks, being able to implement the pace plan, as you were talking about, is key. And then third really is that future proofing idea, where moving to the digital software world allows you to evolve systems over time. It allows you to bring in new standards, new capabilities, without having to deploy new hardware, which is really important in a world and an industry that is evolving very quickly, to be honest.
Yeah. And John-Paul, you talked about future proofing, but I'm also curious about compatibility with existing systems. So what does this mean for compatibility with conventional ground stations?
Yeah, it's a good question. I think it is critical, that compatibility, and it's one of the reasons why that digitization is so powerful. But you can't create kind of a new ecosystem overnight. It has to evolve, and there are a lot of players that need to help to achieve that. So new systems need to work with old systems, but obviously the faster that you can transition, the better for everybody, for the whole industry. It's just that no one can read the future. No one's got a crystal ball, and it is complex. So you have to take it one step at a time and allow things to evolve. It is absolutely critical, though, that standardization is the key. And we've seen, obviously, 3GPP and the mobile world has shown us how it can be done. So the likes of Diffie as an open standard is really important to get the nuts and bolts to work, so everybody knows how to create interoperable systems. That's what's key.
Yeah, I haven't got a lot to add to that, JP. I totally agree. I think the very clever guys who developed the waveforms and for the SDRs, that to me is the key. If we can have a waveform that you can load onto an SDR and be interoperable with the bank of modems in a standard earth station, it's a panacea. But that's where hopefully this conversation is going to go, and the more conversations we have like this will make people realize that's what you need to secure our business going forward.
I think I'd emphasize as well that you've got to remember this is a layered approach and a segmented approach to communications. So when you think about the air interface layer of the communications, even though we're going through a digitized edge device, we're still using exactly the same air interface that we would be using with a conventional modem. What's different is that because it's a virtualized modem, you can have multiple different modems in the same place, operating over multiple different air interfaces. But what actually goes over the air would be exactly the same, whether you have a conventional modem or whether you have a Diffie-based modem. But where you get the real benefits, firstly with Diffie, with all of the work that's being done for compatibility, and Diffie does a lot of work to make sure that all of this interoperability testing is done offline of customer deployments, so that we test it as an organization so that our customers don't have to, or more to the point, actually, as a set of organizations. And secondly, as we're developing for ground stations and edge devices, it's a very similar set of waveforms in both cases. There's a lot of benefits and cross-pollination across the different software radio areas.
Yeah, thank you for that. I'm curious about the benefits of digitization and how they are different between conventional antennas and ESAs. So, Dave, can you talk about the specific benefits for conventional antennas?
Well, that's a very good question, Rachel, and it's a very simple answer. As we move forward in technology to ESAs and some of the great things that JP and All.Space are doing, there's still an awful lot of customers out there that are used to conventional antennas.
Mm-hmm.
So I think for next generation conventional antennas, which I work on, it's something that's very familiar. Now, as Simon quite rightly said, this air interface, the standard link budget when you're looking at satellite communication, you do need to generate an RF wave to travel up to a satellite and back down again. Now, that is a very nice conventional way of doing things. I know that ECAs have got them built into their antennas, but when you look at, if I was going to, and you push me to say what are the differences and some of the benefits, it's that repairability. It's that familiarization. It's the spares holding of all the large networks that are out there at the moment. With a good antenna control system like we've developed, yes, you can do GEO, you can do MEO, LEO, HEO. It's a very simple thing to track satellites and keep on the air. There are, as JP is going to explain, some big advantages of forming the beam electronically. But certainly, what I'm seeing right now, so I have this question quite a lot. Our conventional parabolic antennas have had their day. Absolutely, they will have their day, but they will be around for a very long time, servicing slightly different markets, servicing the more secure and man-portable, lower cost type markets. But certainly, we shouldn't be pitting traditional antennas and ECAs against each other. In the ecosystem of satellite communication, there's a place for everything, and I think we should view it in that way of looking at these two technologies going hand in hand for a very long time to come.
Mm-hmm.
Yeah, I definitely would agree. There's definitely places for both technologies. Conventional antennas, parabolics, have obviously been around for a long time, are robust, are well understood, are relatively cheap and cost effective, and there's a number of solutions that plays very well too. Obviously, with ESAs, as you start to look at sort of mobility solutions, as well as multi-network, that's where they come into their own, and that's where that digitization is key. ESAs are obviously sort of inherently agile, and ours in particular, you can track multiple satellites at the same time. You can repoint in milliseconds, and that agility delivers real sort of value if you have the intelligence at the edge to actually manage all of those links. There's no point in having multiple links if you don't know how to actually get the most out of them. And that intelligence is enabled by that digitization that we're bringing to our terminals in the form of integrated compute and AI, to actually start to control and do a lot with that underlying capability. And it's that kind of software that you can build and the software features you can build on top of that digital architecture that's key. And actually, we kind of see this this journey of the industry and kind of where All.Space is kind of analogous to the iPhone and the App Store in terms of that story. The parabolics kind of traditional landline technologies relied on it for many years. They are robust, they're well understood, they're very easy to deploy, they have a place. They are the sort of the backstop, but with ESAs coming along, we're moving into the world of sort of mobile phones, and we're stepping up in terms of flexibility, usability, and obviously for mobility applications, that's key. But then kind of again in the story with the iPhone, that kind of was a big step change where we kind of saw that critical digitization point for mobile phones and the birth of smartphones, and it brought developers and users that digital platform that they can build on, pairing both reliable data communications with compute. And that's exactly what we're trying to bring with our products. Obviously, with Diffie, you've got that capability from a transport layer, and with the integrated compute, you can really start to build those applications on top of it to do lots of valuable things for the end customers, and that multi-network capability really comes into its own. So yeah, we're seeing a lot of change, a lot of opportunity in the industry with this digitization.
And I think some of the points which both JP and Dave made have got a lot of crossover between them, particularly around the ability to have compute on hand, doing management, doing bandwidth management, doing spectrum management, finding holes in spectrum, perhaps where it's needed, where you've got high throughput requirements. You know, Diffie is very committed to working through on helping ESAs, which is another nascent technology. We have to say it's still a comparatively young technology, just like digitalization. And the market's going to dictate a little bit how that technology evolves, but certainly Diffie is helping with the ESA front. And I think where I see the Diffie specifications going next is perhaps to include some in-band capabilities for things like OpenAMIP, OpenBMIP, to be able to just have that additional antenna control capability built in there. I think it's a great enabler for anything in the transmit chain, whether you're talking about digital bucks, whether you're talking about digital LNBs, that once you've got things into the digital domain with any sort of antenna, there's a lot more signal processing you can add into the mix, which can help all of the swap, particularly the P of the swap situations.
So with Diffie, I remember was started just a couple of years ago, and they've already put out a couple of versions of the standard. How big of a change has that been for the satellite industry in just a couple of years?
Well, I think it's a huge change, because you're basically breaking the whole paradigm of the satellite modem business. There's a lot of chef shows that talk about the idea of deconstructing food. Well, you can talk about Diffie really as deconstructing a modem into a digitizer, which is a common front end hardware that you have to have with all of the different modems. And then on the other side, you've got a software modem, which can be of any sort. You can have multiple software modems. You can have, if you want to stand up more modems within the bandwidth, you can do that. You can move CapEx to an OpEx requirement when it comes to modems, so long as you've got that digitizer and you've got that huge flexibility and future-proofing that JP mentioned a little earlier. So I think it's a huge change, and shameless plug for Diffie. If you haven't downloaded 1.3.0 of the specification, do so, because there's some great new stuff around link establishment in there.
Excellent. Well, excuse me. Well, I've seen many changes in this business over the 35 years I've been playing. I've seen the change from analog to digital in RF. I've seen various DVB standards. I've seen various MPEG standards. I've seen from serial to IP communication. The one thing I love about this business is how much we do evolve, and certainly my customers are looking at this whole Diffie revolution as something as important as that. To be able to transmit your signals without signal degradation to anywhere, to an IP address, is something that, I'll be honest, there are a lot of very, very clever people out there that will be able to think about much more things than I can do with it. But as JP mentioned about multi-orbit, multi-band, multi-constellation antennas, people have been talking to me about that for the last 15 years. It's something that everybody wants to do. But joining that data at the end, certainly in secure communication perspective, was always going to be hard. I don't know quite how we're going to sort out sovereign bunkers and sovereign silos, but having digitized information like Diffie can give us is going to give us the opportunity to do that. So that's what I see.
Yeah, definitely.
Just before you jump in, JP,
Sure.
just one thing that Dave reminded me of is that as far as the industry is concerned, this is as much of a paradigm shift as the shift when we moved from 70 megahertz to L-band IFs.
Yeah, absolutely.
Going from L-band IFs to digital IFs is a similar level of paradigm shift for the industry. Sorry, JP.
Yeah, no, I totally agree. I was just going to chip in and say, as Rachel mentioned, that Diffie's not been going for that many years. But there have been a couple of sort of drops of the standard, and just wanted to kind of explain that I think the mentality is that because the industry is changing quickly, we wanted that speed to get the standards out there, but we wanted to start simple and robust and build on it over time. So as we've gone from version 1 to 1.1, 1.2, 1.3, we're building on that core capability, that core functionality with enhanced features like the link establishment capability, for example, Simon. So yeah, I just wanted people to understand that, yeah, Diffie is not standing still. It's not like it's one shot and done. It's going to evolve and grow in capability with the industry, which is, I think, a really important factor.
And I think just another thing on that point is that Diffie actually has a electronically steerable antenna working group to make sure that the two technologies do complement each other as the technology evolves.
Yeah.
Yeah, that makes sense. Thank you both. All right, so what about adoption? We've been talking about the issue, but what does initial market adoption look like at this point? Where is it coming from? Talk to me about what the demand looks like today and how you expect to see it evolve in the coming years. Simon will.
So I think, as with all of these new technologies, I think it's going to pull through from the military side. You know, it is more expensive initially than a separate modem, but for that there's no such thing as a free lunch. For that, you get a lot of benefits. So that benefit costs a little bit more money initially. But as that grows, we're seeing all of the RFIs that we see are primarily from military, from government users who are looking to take existing modem fleets to be able to have interoperability with previous systems, whilst having the ability and the future proofing to be able to use the systems of the future. So that's where I think I see both the initial adoption, and I think that's where the evolution will pull through, and then moving into the sort of disaster relief and more into the commercial front from there.
Yeah, I definitely agree with that. For us at All.Space, we're definitely seeing a lot of interest from the defense and government users. They obviously have that key requirement of resilience, multi-network connectivity, and are able to explore these new capabilities. They can't deal with single points of failure, so they need that flexibility, and that's what the digitization brings. That said, there are some pretty critical standards that those guys work to. WGS, for example, and I know there's a lot of discussion around how Diffie and WGS can work well together. So it's definitely an evolving process, but yeah, those guys are keenly focused on these types of technologies.
Again, you mentioned WGS. It's a good point to point out that Diffie has a working group as well, looking at that standardization. and I mentioned about the splitting up of the modems, and the digitizers. Well, that also means, to a certain extent, every communication system relies on the link budget, and how you appropriate parts of that link budget to the different subsystems, whether they be the software modem or the digitizer.
Yeah, I agree with both of you. Certainly the people I speak to, and my customers and various sovereign nations who are looking at Diffie as not right now, but coming forward when they're looking at upgrading the infrastructure, certainly will be. I think will be the first adopters. However, in my career, what happens in the military sector, disaster recovery sector, certainly gets rolled out into other sectors as well. Let's not forget the broadcast sector. When we talk about money, when you talk about mission critical data, mission critical live feeds and distribution of live feeds, well, I used to work with some producers that would tell me there's nothing more important than the Super Bowl, nothing. And if you disrupt that, you're in trouble. And many years ago, we worked on video over IP solutions, whereas this could be, might not be in the first adoption, but I absolutely believe distribution over IP of this type of technology can be adopted in many different applications. Not so much at the edge, but certainly edge devices feeding into larger networks. We shouldn't just be looking at military. We should be looking at all communication systems.
Yeah, thank you, Dave. So our last question is looking to the future. What are the next steps and milestones to achieve digitization at the edge?
I think it's very much the same as we had with the ground segment, that you have to have the whole ecosystem together. So it's fine to say, right, we've got this lovely shiny digitizer over here, but what's going to feed it? So it's that evolution of the terminal that can accept the digitizer, of the software modems that can drive the digitizer, and the partnerships that we create, which bring those items together. Those are the key steps which need to all be in place to bring a coherent service to the end user, and to have enough choice in that field to be able to make decisions between different vendors. So it's not just a case of, okay, well, we've got vendor A's offering, but oh, hang on a minute, if vendor A decides they're going to increase their software licensing costs astronomically, we're completely they've got us completely over a barrel. So we want the multiplicity of vendors for competition in the field. And that, again, is part of what the interoperability is all about.
Yeah, the competition, that's a great point.
Yeah, definitely agree there. And I think that only helps with bringing costs down for fundamental components, which is just like, as you said, Simon, a bit of a practicality with digitization. Some of those systems have started off being expensive. Leveraging volumes is a really healthy thing there. So that's only going to help with adoption. For me, that the last point probably just to mention is that ecosystem sort of validation. And again, Plugfest, for example, with Diffie, where you can bring people together, trial and test capabilities and show what works and potentially what doesn't work, and how to fix features and capabilities in the standards in particular is a really important piece of the puzzle.
Yeah. And for me, the next steps and the milestones for someone who produces the edge terminals is absolutely, as Simon said, the ecosystem. It's the digital bucks, the digital LNBs, but most importantly, it's the waveforms. The one thing to make a Diffie edge terminal work is the concept of the SDR with a stack of different modems that you can spin up and uplink back to an earth station, and it doesn't matter what waveform you're using, you're going to be able to get that transmission out. Now, the challenge, or the next steps, the milestones, the challenge is how do we, as terminal operators, manufacturers, get those digitized waveforms? At the moment, the standard guys, the Comtech, the modem guys, that's what they do. They sell physical hardware, and there's got to be a step function change in their business model before we can get Diffie at the edge. that's my that's what I'm waiting for, and that's what these sort of discussions should be about. And hopefully, going forward, we'll see that if we all work together, traditional antennas, ECAs, modem manufacturers, RF equipment manufacturers, because this revolution is coming. You're not going to stop this revolution, and we've got to work together.
And I just want to re-emphasize that kind of working together point, because it is critical. I think it's kind of the elephant in the room are obviously the big constellation guys, right? The Starlinks, the Amazon Kuipers that are coming along, to be honest, aren't necessarily using these standards. So the rest of the ecosystem has to work extra hard to make sure they can stay competitive and be able to offer something that is of equal or better value to those large players in the market. Otherwise, it's going to be really challenging.
That's a great point. Well, this has been such an interesting discussion. It's been great to have the three of you bringing all of your expertise and coming at this from different angles. So really appreciate your time. Simon, any plug for if listeners want to get more involved in these discussions?
So certainly come and take a look at the Diffie website. Come and see us at SAT Show, and we'll be able to show you all of the digitization really working live on the stand.
Awesome. Well, thank you all so much. Really appreciate it.
Great. Thanks, Rachel. Appreciate it.
Thank you, Rachel.